physical structure that we're going to look at is the cerebellum. This makes up about 11% of the brain mass. It's located dorsal to the pons and the medulla. It's got processes or it processes inputs from the cortex, the brainstem, sensory receptors, provides precise, coordinated movements of the skeletal muscles, and also plays a major role in balance. This is kind of our motion computer. Takes up all the information coming into it about where the body is in space and comes up with a plan to move the body where it wants to go. It is divided into hemispheres. Those cerebellar hemispheres are connected by worm-looking like things called vermis. There are folia, which are transversely oriented gyri. Each hemisphere is divided into three lobes, the anterior, posterior, and flocculonodular. It has a thin cortex of gray matter, and that gray matter is distributed with a distinctive tree-like pattern on top of the white matter, and collectively that is referred to as the arbor vitae, which literally means tree of life. There are Purkinje fibers originating in the cortex, and they are synapsing with the cerebellum. The cerebellar homunculi shows sensory maps of the entire body, you will recall. So here's the cerebellum. These are the arbor vitae. There's gray matter around the surface. It is behind the pons, medulla, and separated by choroid plexus. So here it is in anatomical position, and then another closer look. And this is if you take it out and lay it flat. So the cerebral peduncles the fibers are ipsilateral. They're to and from the same side of the body. They're three pairs of fiber tracts that connect the cerebellum to the brainstem: the superior cerebellum, the middle cerebellar, and the inferior cerebellum. Superior connects to the midbrain, mid to the cerebellum, and the inferior as well to the cerebellum. Superior cerebellum to midbrain, middle pons to cerebellum, and inferior medulla to cerebellum. The cerebellum is fine-tuning motor activities, so it's going to receive impulses from the cerebral cortex about the intent to initiate voluntary muscle contractions. It will receive signals from the proprioceptors throughout the body, as well as visual and equilibrium pathways that inform the cerebellum of the body's position and momentum. The cerebellar cortex will then calculate the best way to smoothly move the coordinated contractions to get to us where we want to be, and it will send that blueprint of coordinated movements to the cerebral motor cortex and the brainstem nuclei. Neuroimaging also suggests that the cerebellum plays a role in thinking, language, and emotion. And like it does for motor processing, it may compare actual output of higher functions with expected output and adjust accordingly. There's our homunculi within the cerebellum.